When you take the square root of a number, if it doesn't come out nicely, you're going to get some big nasty decimal. So square roots of numbers, and if you have something like 36, you take the square root, you get 6, that works out nicely. But if you have something like the square root of 7, you're going to get a nasty decimal answer for that. It's going to be an irrational number. If you don't remember what that means, it's a number that has infinitely many digits and it never ends, never repeats. There's no pattern to it. It's just this infinitely long string of digits. And so when we have these irrational numbers in the denominators of fractions, it can get a bit messy and make computations a bit harder. So in mathematics, we do something called rationalizing the denominator, which is getting square roots out of the denominator, turning the denominator into a rational number. So that's what we're going to do here. So we have, you can see, the square root of 7 on the bottom of the fraction. So that's going to make things a bit difficult to deal with when we have that on the bottom. So let's rationalize the denominator. And to do that, what we can do is we can multiply top and bottom of the fraction by whatever square root is on the bottom. And if we do that, it'll clear out the square roots. Let's talk about how that works. So first of all, on the top, we get 2 times the square root of 3 times the square root of 7. Well, when you're multiplying radicals together, the rule is you multiply insides with insides and outsides with outsides. So it may help to think of that as 1 times the square root of 7. And then on the outside, we've got 2 times 1 is 2. Then on the inside, 3 times 7 is 21. On the bottom of the fraction, well, let's first take square root of 7 times the square root of 7. So again, using our rules for multiplication of radicals, this is the square root of 49. And the square root of 49, that would be the number you'd have to multiply by itself to get 49, which is 7. And you can see here then the square root of 7 times the square root of 7 is 7. And if you think about what it means to take the square root of something, that makes sense. Because the square root of 7, this is the number that you would have to multiply by itself to get 7. And here you've multiplied it by itself, so you should get 7. Alright, so then on the bottom of the fraction we have 5 times the square root of 7 times the square root of 7. Well, the square root of 7 times the square root of 7 is 7, so then we get 5 times 7. 5 times 7 is 35, so this is the fraction that we get. So that is has a rational number as the denominator. Now there's another case that we can have when we're rationalizing the denominator, and that's when there's not something quite so simple as 5 square root of 7. Before we get into that, let's talk about something called conjugates. So conjugates are when you have the same binomial, but with opposite sign between. So if we look at x plus 4 and x minus 7, these are conjugates. They are exactly the same thing, except for one has a plus and one has a minus. And something special happens when you multiply out conjugates. You guys have probably seen this before in previous lessons. So if we were to FOIL this, x times x is x squared. X times negative 4 gives negative 4x. And then 4 times x is 4x. And 4 times negative 4 is negative 16. Then you can see the middle terms here, negative 4x and positive 4x. Those cancel each other out, and we're left with something called the difference of two perfect squares. So this is x squared. 16 is 4 squared. Difference means subtraction. So this is the difference of two perfect squares. And this is going to happen anytime we multiply conjugates together. Those middle terms are going to drop out. So if we have something like this, we can exploit conjugates to rationalize the denominator. So if we multiply top and bottom by the conjugate of 5 minus the square root of 3, that will clear out all the square roots. Let's take a look at how that works. So we're going to, instead of taking 5 minus the square root of 3, take the conjugate of that. That's 5 plus the square root of 3. And if we multiply top and bottom by that, it will get rid of all the square roots. Be careful when you multiply these. These are binomials, so we should be using FOIL. So let's take a look at the bottom first. So we get 5 times 5 is 25. 5 times the square root of 3 is 5 square root of 3. 5 times, negative square root of 3 times 5 is minus 5 square root of 3. And then square root of 3, negative square root of 3 times the square root of 3, that's going to be negative 3. Then this will simplify down a little bit more. Here we've got a positive 5 square root of 3. Here's a negative 5 square root of 3. Those cancel out, and we get 25 minus 3 is 22. Then on the top of the fraction, multiply this out again. 2 times 5 is 10. 2 times square root of 3 is 2 square root of 3. Then square root of 3 times 5, that's 5 square root of 3. And the square root of 3 times the square root of 3, that is 3. Then if we combine like terms, 10 and 3 make 13. And then 2 square root of 3 and 5 square root of 3 together make 7 square root of 3. So here it is with a rationalized denominator.